To prepare us for the next section, where we will be adding or subtracting rational expressions that don't have the same denominator, let's talk about how you can change the denominator of a fraction. When we talked about simplifying, we saw how you can cancel or divide the same thing on top and on the bottom and get an equivalent fraction. But you can also go the other direction and multiply by the same thing on top and on the bottom. So that comes in handy when you want to rewrite a fraction as an equivalent fraction with a different denominator. So for example, we can take the fraction 2/5 and write it as something over 30. What's the something? Well, to figure this out, we have to think, what do I have to multiply 5 by to get 30? If I'm going to turn a 5 into a 30, what is the factor that I would have to multiply that by? Answer? 6. Now, if I'm going to multiply the denominator by 6, that's perfectly legal as long as I multiply the numerator by 6 at the same time. Because then I'm really multiplying the whole thing by 6 over 6, which is 1. And when you multiply a number by 1, you just get that same number. So when I do multiply by 6 on top, 2 times 6 gives me 12. So that's what goes in place of the question mark, the number 12. 2 over 5 is equivalent to, it represents the same value as 12 over 30. So let's try another one of these. What does the denominator have to be in the second fraction here in order for these two fractions to be the same? 4 over y equals what over 5y cubed? So to start with, think, what would you have to multiply by to get from this denominator to this denominator? Y times what gives you 5y cubed? Well, we're going to have to multiply by 5, and we already have 1y, but we need 2 more to get y to the third power. So the factor that we have to multiply by is 5y squared. So then we'd have a 5 times y times y times y. And so whatever we multiply by on the bottom, we have to multiply by the same thing on top, 5y squared. So what does that give us when we multiply the top by 5y squared? Well, 4 times 5y squared is 20y squared. What about this one? 10 over x minus 4 equals what over x squared minus 16? So we have to figure out what we have to multiply the first denominator by to get the second denominator. And that's a lot easier to see if we factor that second denominator. So x squared minus 16, when you see something like that, you should immediately think, aha, difference of two squares. That's one thing that's being squared minus another thing that's a perfect square. And we have a special factoring formula for that. X squared minus 4 squared factors into two factors that both start with x, both end with 4, but one of them has a plus and one of them has a minus. So to get from just x minus 4 to x plus 4 times x minus 4, what is the missing factor that we have to multiply by? Well, that would be x plus 4. So to multiply by x plus 4 on the bottom, we better multiply by x plus 4 on the top at the same time. So what we end up with in the numerator here would be the 10 that we started with times the x plus 4. So you could either just leave it like that, 10 times in parentheses x plus 4, or you could go ahead and multiply that out and say it's 10x plus 40. So this is a skill that will come in handy in the next section, where we will be adding or subtracting fractions that don't have the same denominator to begin with. The trick is to get them to have the same denominator. Turn them into equivalent fractions that do have the same denominator as each other. And so to prepare us and whet our appetite for what's coming up in the next section, let's remember how that works when you're just working with numbers. Good old numerical fractions. So let's say you had to add 1/2 plus 2/5. You remember how that works? They don't have the same denominator, so you have to get them so they have the same denominator. You have to change 1/2 into something else and change 2/5 into something else where the two something else's both have the same denominator. So we look for the lowest common denominator, that is the smallest or lowest number that is a multiple of both of these. Here that would be 10. We can take this 2 times 5 and turn it into 10. And we can take this 5 times 2 and turn it into 10. And whatever we multiply by on the bottom, we have to multiply by the same thing on the top. So 1/2 times 5/5 is 5/10. 2/5 times 2/2 is 4/10. And now that everything is in tenths, we can add. 5/10 plus 4/10 equals 9/10. If it helps you to understand what's going on in this example, when we add these two fractions together and get this, take a look at this demonstration that will help you visualize what's going on. Here we have 1/2. We divided the circle into 2 parts and took one of those 2 parts. So that's 1/2 of a whole circle. And here we have 2/5. We divided this circle into 5 equal parts and took 2 of those 5 parts. So this is 2/5 of a circle. To add them together, well, they're different size pieces, so that makes adding complicated. So we change 1/2 into 5/10. We divide this up further, so then instead of just 2 pieces, things are divided up into 10 pieces, and then the 1/2 is 5 of those tenths. Meanwhile, over here, we divided this circle further so that this is in 10 equal pieces, and 2/5 is the same amount of circle as 4 of those tenths. And now we can put these together. 5/10 and 4/10 together add up to 9/10. Let's try one more example. 2/9 plus 4/15. So to add them, we need a common denominator, preferably the lowest common denominator. How can we figure out what that would be? Well, if I factor these denominators, 9 factors into 3 times 3, and 15 can be factored into 5 times 3. So if we want these denominators to be the same, they have to have all the same factors as each other. This denominator here has a 3 times a 3, but what is it missing that this one has? A 5. So this guy looks over at the other denominator and says, I want what you have. You have a 5, I want one of those too. So we can multiply by 5 on top and on the bottom to get 3 times 3 times 5. Then over here, we want this to be the same as that. It's already got a 5, and it's got one 3, but it needs another one to be exactly the same as this guy. So here, in this second fraction, we're going to multiply by 3 on top and on the bottom. So when we do that, remember we multiplied by 5/5 here, and we got 2 times 5 is 10, over 3 times 3 times 5 is 45. And here we multiplied by 3/3. 4 times 3 is 12, 5 times 3 times 3 is 45. Now that they have the same denominator, we add the numerators and get 22 over 45. So this is the same approach we're going to be taking in the next section when we have some variables involved, fractional expressions that aren't just numbers. We're going to factor the denominators, figure out what missing factors we have to multiply on to get the denominators to have all the same factors as each other, and then we can go ahead and do the adding or subtracting.